recording. And thank you all for joining today. This is our second event of this working group on social tech and modeling for knowledge and action, or stamina. Um, and just as a fun little way to start, I thought everyone can open up the chat right now and just type in the city that they're coming from. I'm going to open up the chat and put um, Montreal. Um, Yeah, so Zachary, my co-organizer, is also here, and I think I just want to note that, like many scientific initiatives, we sort of flourish in a free society, and we aspire to be sort of global. And I think it's part of being human to feel solidarity with citizens that are far away, that are living scared due to war or other things, and that there's always value to hope uh, for a better tomorrow. And I sincerely believe that science can be part of that hope. And I think Martin probably shares that view. And I'm grateful that Martin accepted our invitation to speak today on the topic of where science is going in this age of AI. So I want to mention that we do have some uh, upcoming talks. So Jing is going to talk next week on some um, work. She's done a lot of work on multi-agent simulations with LLMs and understanding cooperation among them. And then we'll have Marc-Antoine coming on the 24th, where we'll go back to sort of knowledge commons ideas and how they're being affected by modern AI technology. Um, just some notes about organization. So this is sort of designed to be a sort of responsive communication channel for research at the intersection of social science, social tech, and the study and promises and risks of large language models, in particular AI agents. The talk will be recorded, so if you don't want to be recorded, you can turn off your screen. You can always check for info on our website, which is complexdatalab.com/stamina, to see, what upcoming talks are and to sign up for announcements. So for this talk, my co-organizer Zachary is going to be on the chat, and you can ask clarification questions there during the talk, and during the Q&A, you can raise your hand, and we'll bring you up to ask questions. So today we have Martin. So I got to know Martin while talking with him while he was building his startup Tiptree Systems together with another Mila grad, Nassim Rahman. And I've come to realize Martin thinks pretty deeply about systems issues involving mechanism design and other things, which I think this talk shows he's been sort of thinking about science in particular. And I thought it'd be fun to have him up here to give a talk on that. So Martin, please go ahead.
Great. Thank you for the introduction. Can you all hear me okay? Yeah, okay, good. Yeah, so let me just share my screen. Yeah, I'm currently I have a postdoc entrepreneur fellowship from Ivado. I'm co-supervised in my research by Hugo Larochelle and Chris Powell, and my co-founder is Nassim Rahman for Tiptree Systems, as was mentioned. Um, yeah, I've been working on, I would say, like social technology since I was probably 19 and did my first startup, basically working in developing countries and trying to leverage a kind of asymmetry in terms of like the value of intellectual property across different places and as a mechanism to try to get, artists living in developing countries out of poverty. That was like the first attempt many, many years ago. And then I've worked on a variety of different topics since then. What I'm going to talk about today is going to be a little bit freewheeling. So I'm going to talk about a few different things. So it's kind of like a mashup of a few different topics, which at least for me make a lot of sense coherently, and hopefully I'll try to make it make sense for you as well. And if you have any questions, feel free to jump in and ask. Totally fine with this. So the first thing I'm going to talk about is kind of like science, generally speaking, like what is the system that we're kind of ensconced in? So like a pretty abstract notion. And then I'm going to talk a bit about how what we're trying to do in the startup is like attempting to solve some part of this problem. And then that's going to lead into like a bit more of the actual like experimental work that I've been doing actually just over the last week or two. I'm going to present some very half-baked work that I think is pretty exciting. And hopefully I'll convince you that it's also exciting from like a elicitation of persona type perspective for LLMs. Um, and um, yeah, so that's kind of the structure of the talk. So starting off, like, what am I like when I say science? What is it that I'm talking about? So for me, it's this attempt to compress the universe into the human brain. And so there was a very nice paper, and you can like grab it from, this QR code for the next few slides. I'll have like the work reference like that, where Thurston is describing his take on what is, at least in mathematics, like, what does it mean for something to be valuable? So for him, it's about like a proof actually has social value. Okay. It's not just that like something is correct for 200,000 lines of lean that no one has verified. It's correct if we can convince other people that this thing is correct. And so what I like about this definition also is that it kind of captures both an understanding about like truth with respect to the universe, but also about communication, right? It's fundamentally about getting this information into somebody's head. Um, yeah, nice. Um, and one of the things that I think science has a problem with right now is that basically a lot of it is being, um, I mean, automated, as we know. And one of the ways that this is happening is like we're seeing that forecasting models are on track to be super forecasters, like they're already better than the median of a bunch of random people about a topic, and they're on track to be superhuman. So what that means is that like we are able to predict and control things that we don't necessarily understand in a way that we have not been able to previously. So that's kind of like part of setting the scene of where we are in this moment. And how that applies directly within science itself is that you have this. It used to be that you could have like a generator of a good paper would be able to do like very clean communication in a certain way about the topic, and that would like ease the way that you could like understand the language. My supervisor, Chris Powell, had a phrase for this from about a decade ago, where he would say like, um, he would when he was like when I was first starting out, he's like talking about the ConvNet reviewer. Like it'd be very easy to like just scan through a paper and see if it was crap. And it's becoming harder and harder. And I think we're on track to it. The ConvNet reviewer is no longer going to be able to catch such things at all in the next few years. And so that's what I'm saying with like the plausible science is like plausibly correct. Like the form is no longer um, the fact that it like obeys the form well and is communicated well no longer means that it's actually true. Because the actual ability to do good science has now been to some degree decoupled from presenting and communicating about the science. And I think it's actually harder to do, at least right now, it's definitely harder to do good science than it is to, make something that looks like it's good science. Um, and that would be fine if nobody were incentivized to do bad science. Why would somebody do bad science? But because we have, our academic objective functions out there that are, publish or perish, like people don't want to perish. And so they have an existential push to go and try to game this function. And so here I'm like pointing to this Guardian article where there's like a guy who basically started a little call it like a consulting company where he's getting a bunch of high school students workshop papers at some top tier ML conferences. Um, Give you 10 grand and I'll get you a workshop paper kind of situation, and then that kid can then go and use it in their college application. Right? There's a bunch of incentives here, and the other piece is like it's it's no longer the case that you can do credit assignment to that person. It's like becoming easier and easier to manufacture something that is creditable, that at least passes some amount of peer review. Um, and as we all know, the burden on reviewers is increasing and increasing. And so that's all like to cue up this question, like how should AI systems interact with the human-centered scientific process? And that's kind of like a one of like the larger questions that I'm trying to tackle from a few different directions. I would say that's the question that I'm trying to tackle from the startup. So I'll start with the startup and like what we're trying to do there, and then I'll go into experimental results and the research direction, and I'll try to tie them together for you. So the idea here is basically we're building this AI assistant for researchers. It has like all the same stuff that you would imagine that an AI assistant would do, but like the motivations of why are we building this? How are we trying to bring it about? And what does it enable as like a secondary function? It's like the key here. The reason we're doing this is basically we think that if you can accelerate, well, I'll show you what this graph is. Basically, you have, if you look at CRISPR, like which is a very important technological breakthrough for gene editing, it took a long time for people in a bunch of different fields to talk to one another to make that like discovery of this mechanism into something that you could actually use to do gene editing. Okay. And the problem is basically that information doesn't flow easily around social networks. That's like the actual big issue here. Okay. So this coordination across large networks is actually the fundamental problem, I think, to scientific progress. This is my, core hypothesis that I have. And the evidence that I have is basically when I was around at Mila in 2017, I kind of knew what people were working on, so I could ask them questions. Today, I have no idea what the hell anybody's working on. Very hard to ask them questions. Then the network is very large today with 1,400 researchers. And if you look more broadly across, that's just within my institution. I can go to this person's desk and try to find them, right? So if you go and you look at the, you know, tens of thousands of papers being published every year, it becomes even harder, right? Far harder. And you can see that like it's not it doesn't scale linearly, right? This is scaling with respect to the number of nodes, right? We're talking about edges. Like how do I figure out who from me over here, how do I find the right person in the graph is the core problem. And so you kind of have two ways to approach this problem. The first one is like you do manual search, and that's like I'm going to go and read a bunch of papers, and I'm going to try to infer who the right person to collaborate with or to ask a question is. Um, Obviously, like whether or not someone's open to collaboration is conditionally dependent on a bunch of private information that they have. It's not available to you just on the internet that they like just got a grant to work on something else or like they're about to submit something that they really care. Like you don't know this, right? So you have to like send a bunch of emails and talk to a bunch of people to try to find that person. So an exhaustive search. You can also do broadcast, just like I'm just going to at channel Slack or like, I'm going to try to get PR about, my offer, whatever it is. Um, which basically requires lots of other people to do computation for you about this, but also it's hard to reach those people still. So you have to like get into some distribution channel, which is hard. And what we're trying to do, yeah, and another mechanism here, this is like, how do you use AI to solve this? So one of the ways is you could use something like Bordy, which is basically going to sling out a bunch of connections to people. Like, I think you two should talk based on a conversation. And like, I'm not really involved, but I looked at their LinkedIn and I think, that you should talk to them. And this has like very low success rate in terms of like how often people are willing to actually engage with one another. Like how does it and basically it's because it doesn't have context, right? It doesn't know which person just got the grant and which person just did the lit review on the same topic, right? That would tell you that like, oh yeah, like there's an opportunity for collaboration here. And so what we're trying to do is to build this thing where we have each agent has access to private data for that person and is involved in the work that they're actually doing. And then you have another agent which can look at the private information, but the only thing it does is routing. Okay. And that lets you figure out, oh, this person who is just on the lit review should, like, when they're saying, I want to collaborate with other people, it's like, out of all of the people in the network, who should they collaborate with? We actually know who just got the grants. We actually know who is also just doing a lit review. We actually know like a bunch of other signals that would say, and you don't say to that person, here's the list of people. What you say is, I'm going to ask those people if they want to match for this opportunity. So you're not broadcasting either. It's kind of like a smart search over network. And what enables this is that if you basically, what you need to do is to model well the interests of both sides. That's like the hard part. That's like, why does it make sense to use AI today? Why couldn't you have just done this 10 years ago with like like a much simpler model? And the answer is that it wouldn't have done a very good job of A, being involved in the actual execution of like the research with that researcher, and B, it wouldn't have been able to use that to infer the preferences of the people involved. And so we think that now is when you actually can start using systems like that to do that kind of mediation. So concretely, it's like people are using this agent for their work, and then it builds a real-time map of who knows what. And then it lets us figure out like, oh, like this person should be talking to that person. And so this person says like, sure, I can use a collab, and then it makes the connection. So the question that I was starting out with was like, how should AI systems interact with a human-centered scientific process? And one of the answers that we have is by creating a network of researchers coordinated by AI agents. So all that the AI is trying to do in this network is, at this point, is to try to, I mean, A, help you to do your research in all of the ways that LLMs are useful for, but B, to be able to then use that information to do routing across people to help you solve this search problem over large social networks. So it's not a social network in the sense that like you're going to connect with people on a platform or something like this. It's a social network in the sense that like there exists a social network that is hard to search over, but you can actually do it in a better way that is privacy preserving. Um, okay, so now assume that that works. Okay, and this is where we get into the speculative fun stuff. Right now, the network is small. It's like hundreds of people, right? Assume that this gets really good, and assume that some portion of the questions are things like, you know, reputation based. Essentially, people are like, I am the best person to ask questions about this. In academia, we sacrifice a lot in order to be known as the best person to ask about something. That reputation mechanism matters a lot for getting grants or getting tenure. Um, and people evaluate us based on our Google Scholars and our H index and this and that and the other. And we also know that those are very bad ways to measure people because they are easily gamed, right? And so if I am proposing to build a router that is using this kind of reputation and understanding of different people, who is to say that, some person might not come along and say, I would like to rank highly on this. I would like to be known as the person who is central to this social network. And I'm going to take actions to do that, right? So how do we build a reputation system that smart people can't beat? That's the hard part. So assume you build this network, assume that the agents are really helpful for researchers, assume that it can like do all this, and then how do you make sure that that routing can't be gamed? And that is a hard problem. And there's a couple different ways that you could approach this. I'll give you a few of them, and then we'll go into like the fun one. Um, so, and I mean, these are gameable metrics, right? So, like credentials, like I have a PhD. Does that mean that I'm an expert in whichever topic? Maybe, but it was last year, and then it's going to be 3 years ago, and then it's going to be 10 years ago, and it's going to get stale. And how do you know that it like the domain that I'm actually an expert in? Or you could look at like the papers that I'm publishing. How do you know which parts are my contribution? How do you know what I'm currently working on in this moment as opposed to 6 months ago, right? So it gets stale as well. Um, if you look at citations, there are citation rings all over the place. I was a tech chair for ICCV, so I saw just how bad it is behind, under the hood of like how people are trying to game that system with things like um, domain conflicts, as an example. So people, will load up a kind of domain conflict so that nobody from like a particular set of institutions will be able to review their work. There's a lot of ways that people are trying to beat the existing systems for how we evaluate science. Um, and so we want something that like is very, very hard to break. So here's what I propose. Here's what we're working on. A reputation system built on identifying people who are reliably non-consensus and correct. Okay. So what do I mean by this? So non-consensus means like if you asked many people what would happen, in terms of progress on an AI safety benchmark. okay? Like ARC AGI 3, whatever it is, okay? In, I don't know, September, okay? So, so you've got some months, right? How do you know, like you get some distribution, right? And so then if somebody turned out to be like way outside of this distribution, but also correct about their prediction of how progress would advance on this important benchmark, um, right? They'd be both non-consensus and then be correct. And it's very hard to game this because they would have to basically be able to control the outcome, which is a lot of people in the community are looking at this benchmark. And perhaps there's like two ways that they could do that kind of prediction reliably. Okay. The first is that they control the outcome. They're like the best researcher in the world. They're able to go in and just like, clean the clock of whatever benchmark that they would like. That is one way that they could solve this. The other is that they have a better world model of the system out there of people who are making progress on that benchmark. In both cases, I care a lot about what that person has to say about the topic of advancement on benchmarks like this one and probably related topics. That's like the key jump here, which is like probably related topics. And so what that does is it reduces the problem of trying to say like, oh, this person, is very strong at this topic, right? And I should believe what they say about this topic, um, to doing a similarity check, right? Between like how similar is this topic to the set of topics that this person is reliably non-consensus and correct about, right? And the reliably piece, what that is doing here is it's giving us that maybe they're lucky, the first one. But then if you keep doing this, it basically gets harder and harder statistically for them to be both non-consensus about something and also be correct about this. Now, you might be imagining, what the hell are you going to ask me to go and do a bunch of forecasts like, every week about different things? That sounds like a pain in the butt. So now it brings us to basically how do we automate, okay, using LLMs, persona extraction, and then to get a proxy of this person that's making forecasts. And then we can evaluate those forecasts, okay? I put this in here because, what we're looking for are the people who are like the very best in the world. Like there's somebody out there who, I don't know if you've seen Unbreakable, but the premise is basically that like, if you look at the statistics of all the people out there, um, you've got Samuel L. Jackson and he's like in a wheelchair and he's like, if I, the slightest thing that will break the bones in my body, right? He's very, very weak in this film. But he looks at the statistics of the people and he's like, there must be someone out there who can just survive anything and I need to find them. And that's like the premise of this movie. So statistically out there, somebody is like very wrong about everything and they've just made like terrible predictions. And there's some people out there who are like, not just super forecasters in the sense that have the skill of predicting, or identifying base rates and then figuring out, future events effectively and better than others, but that is like consistently, reliably able to do this about specific topics. And the goal here is basically to find them without having to pester the hell out of these people. So now we get into the fun experimental work. Um, so there's this data set called Forecast Bench, and they found a bunch of people who were super forecasters in the sense that they had looked at that they were consistently not as much non-consensus, but like they were looking for people who were like able to predict things better than other people consistently. And then ask them questions like, will there be more than 25 named storms during the Atlantic hurricane season? And they'll give them some background. This thing came off of Polymarket. The market price there was 54%, which is basically some sort of statistics around, what some crowd thinks. And this is like a real money market. People have some incentive to, do things to reveal private information or to do things in order to make their money. There are also other incentives, that can screw this up. Although I don't think a lot of people are like have a high incentive to like artificially inflate the likelihood of there being lots of named storms during the Atlantic hurricane season, but who knows? Maybe some weird oil speculator or something. Yeah, and then the super forecaster basically looked at a bunch of data. Okay, so they were like, okay, they found a bunch of base rates. And then they like built up, they like looked at a bunch of URLs to get some information about those base rates. They were looking at like NOAA for like forecasting this range, or like this the higher end of the range. Like, but also I'm gonna adjust this. So there's this other thing, like this particular type of, climatological thing that might affect it and change, or like suppress this tropical activity. Um, and so they like had a whole reasoning chain, and they came up with some like some number that was like very different than what the median forecaster, right, or the market price on this event was. And as an aside, they turned out to be correct. But you can look at the statistics of this data set, okay, and you look at like the super forecaster median. So if you take all of the super forecasters and you look, this is at their forecasted the probability of an outcome on a particular question, and like everything resolves to 0 or 1, right? And there's some set of things which it's very hard to tell if it is like true or false. Like, what is the temperature going to be on this day next year? Is it going to be higher or lower than today? Is like, who freaking knows? Like, it can be very hard. You can easily describe forecasting tasks that are very hard for someone to reliably say. And so no person in their right mind is going to say, for sure it's going to be higher, like yes, like 1. That would be wrong. So what you do is you probably say like 50%. I don't know. Might be, might not be. Then you can look at the public. So this is basically like people who are other people that they asked, humans who are not known as like very, very good, like sometimes professional super forecaster type people. And you can look at the statistics of like how they make their predictions. Um, and this is like where we get into the fun results from last week. Okay. These are some experiments that I'm running. So on the top, you've got an 8B LLM, okay, 8 billion parameter LLM. And on the bottom, you have an instruct. So this is like a pre-trained model. So it's just doing like next token prediction. And this is a model which is doing like, post-training. So you can do like PPO, like, proximal policy optimization against some preferences, whatever. Oh, you're a good assistant, right? With a capital A, you're going to be very helpful, and you're going to write all my code for me and like make no mistakes, right? That can do that sort of thing. This is just like eating a ton of data from the internet, okay, and predicting the next token for 15 trillion tokens or whatever. This is like a llama 3. Okay. And the knowledge cutoff is before the date of when the super forecaster was making their predictions. So it hasn't like seen some information here. What you can see is that it has no problem, okay, fitting that distribution of forecast and trying to emulate it. And if you fine tune, or sorry, not fine tune, post train your LLM, what happens is that it basically tells the model to not split the difference. Okay. It's like, is it going to be, warmer? Like the question is, will it be warmer on this day next year? It's going to be like, yeah. Like, yes, it will be. Right. It doesn't know how to have calibrated uncertainty. Okay. And it doesn't know how to like take on a persona. Because it has a persona. It is the assistant. Okay. But we have this tool, apparently, which is like the base model, which is capable of, and this is, I'm going to speculatively, like, I suspect that it is to some degree, and I think there's a growing body of evidence for this view, able to kind of take on a set of personas at once, kind of. So it's able to simulate a lot of like the median of a lot of different predictions. And so it can have calibrated uncertainty as a result of seeing like it's not just one particular thing. It's not being forced to collapse into just one thing. Um, so here's another experiment I ran where I basically told both models, this is instruct on the left, and this is the base on the right, to take on a persona. Okay, so you're going to be like the base rate anchorer, you're going to be a Bayesian updater, you're going to be a bold extremist. Okay, and then this is the numerical output. This is like an expected calibration curve. Okay, so it's basically like if I say that an event will happen 20% of the time, is it the case that 20% of the time it does happen? Right. So if, it's fine if like if you're saying like this thing is 50%, like that it will be, warmer on this day next year. It could be the case that 50% of the time you're right for stuff like this. And it turns out that like these base models are like very well calibrated. And this isn't totally new because like the GPT-4 paper like mentioned this as well. In their technical report, they observed that basically doing post-training with PPO made models have very bad calibration curves. Um, but basically what I'm showing here is that like you can to some degree, oh, first off, this still holds, which is interesting to me because GPT-4 is a while ago. And it wasn't clear to me that this was like a statement that held for all models. And also that you can like skew these things by taking on different personas. Um, Now, that doesn't get you all the way there. Okay. What you actually care about is if I give it a persona, okay, of someone, I give it some information about this person. If I give it more information about them and they are strong, right, at predicting whatever topic, is it the case that they can, like, the model will do better, right? Because in order for this whole thing to work, it needs to be the case that the person who's consistently, who's the world's authority, who like is of high reputation, who does know or should be of high reputation, if we can score them well, um, like their information, if there's a bunch of information about them that is supporting of this, that their model should be able to do better, right? And similar in a similar way to that person. Okay. And yeah, basically, as we give the model more information about this person, okay, we see that it's like, yeah, skill tracking. Basically, this is like if we give it more information and that person is good, then on similar questions, this model will do better. This is on using the base model because I mean, as I showed, like the base model is the one that is actually calibrated, so we should probably care about it a bit more. At least, again, stuff I've been doing this last week. Um, yeah, so this is now I'm just gonna get into a little bit more like how did I actually run these experiments? Like what are we actually talking about? And then I'll pause and we can have a chat. Um, so yeah, basically you've got all these different kinds of questions, and they have like different resolution dates. Okay. So like 7 days out, 30 days out, 90 days out, all these things. And you've got like ground truth that comes from like Wikipedia and temperature records and things like this. Um, and I want to explain a couple more like granular pieces about this data set. Basically, you look at Breyer score. And so Breyer score is basically a particular measure. And if you were to guess, 50, like 50% of the time, every time, Breyer score would be 0.25. That's basically like random chance. Okay. And then for the general public, they'll get about like 14% on this data set. Sorry, 0.14 Breyer score. And then super forecasters do like 0.11. It doesn't look like a lot, but it is. If you look at some of these questions, it ends up being tough. Yeah, will there be more protests in Montenegro by, July 28th, 2024? And so you have like a forecast trajectory for this person who is like updating their forecasts. And then you ask, will there be more than 25 named hurricanes, right? A totally unrelated topic in the 2024 season. And then you give this to your base model and you don't actually put underscores and it will like make a forecast, right? It'll make a forecast that is like real good, apparently. So this is some results that I was just getting. I'm calling this like a family of shots. So basically, this is like conditioning on the previous forecast. So you give it like the initial forecast, and then it outputs something, and then you give it the next prompt piece, and then you ask it for the next piece. There's a ton of details around like how do you do constrained decoding and stuff like this that we could get into. But yeah, basically, um, yeah. So I was able to get basic models to do this very well. And it turns out that it's like, honestly, my takeaway from this was like, wow, these questions are not as hard as I thought if you have a model which is calibrated. And you give it some like conditional information about kind of the distribution of experiments to run. Um, or the conditional distribution based on the kinds of like the distribution of what super forecasters are saying. Basically, it's able to learn like, yeah, I should be saying like that certain things are like quite unlikely or not sure, or sometimes like quite likely, and that that's actually like a good strategy here. Um, this was a kind of interesting thing to see as well. Basically, the like the longer term forecasts ended up being easier for the super forecaster. And I think this is basically because they're able to go and look at web resources and then figure out like longer term trends. Like it could be like currently it's going to be like this, but that it's going to evolve, right? They're actually able to like take in that information in a better way than our model was. And yeah, so that's what I have on this piece. One last piece, and then I'll stop. Um, there's another project out there called the Good Judgment Project, and they have like 3 million forecasts from a lot of people. And they basically had these people do like an IQ test before they did all these forecasts. And so you have all these different dimensions of like what this person's different traits are. Like they had them do like Raven's progressive matrices and stuff like this. And what I did was I was trying to see if the base model would be able to predict the other variables from that set. And basically, yeah, I was that's like I don't have great results yet. A work in progress for this. The way I set that up is basically like given a participant and their distribution, then you're going to be predicting another thing, right? And so it's basically looking at like it's kind of a correlation metric, but what I'm sort of looking for is whether or not the LLM, these base models, are able to um, like model out a particular persona well and like fill in the blanks kind of for it. And like what kinds of information do you need in order for it to um, be able to adopt that kind of persona and then like make predictions like it. So what I'd like to do is to get away from having a condition on real forecasts, but still induce the distribution of forecasts that that person would make. That's kind of where I want this to go. Yeah, so I'm going to stop here. That's like the progress on building a reputation system and identifying people who are reliably non-consensus and correct. And I told you a bunch of reasons why I'm curious about doing that. And yeah, thank you for your time and listening.
Great. Thanks so much, Martin.
Yeah,
Um, yeah, so
I'm
we
gonna
have
stop
we
sharing.
have
Yeah,
some nice time for questions now. I wanted to jump in and just have you talk a bit about something about the link between the first and the second part of the talk, because I
sure.
think I kind of missed it, and like I'm realizing now, and I want to sort of make that bridge
Yeah,
thicker. Um, so the goal was to sort of find these people that are reliably non-consensus and correct. And then the second part of the talk was like motivated by like a detection approach, or was it like a modeling approach to sort of better understand the persona properties of these people for an eventual detection?
great question. Yeah, I think I missed how yeah, I think I did not actually explicitly say this.
Right.
So if you can look at forecasting, like event forecasting, as like a forward prediction of like this person and their world knowledge and all this stuff makes a claim about the future, and then we have to wait a while to see whether or not it comes true. And like people are doing gambling basically on top of this in prediction markets, whatever.
Mhm.
Less interested in that. What I'm interested in is given that that person made that forecast, what can you infer about that person? Or given that a proxy for that person, conditioned on interactions with them, that's trying to model them out, made a forecast, what does
Mhm.
that tell us about that person? And the reason why I care about that is twofold. One is if you use the proxy, you don't require this person to do all that cognitive labor of actually like, given what I know, I'm going to like make a conditional forecast, which is a pain in the butt. And it's like hard for humans. It takes a lot of time and effort. And most people don't want to do that unless they're getting paid $500,000 for revealing,
Mhm.
information on the poly market or whatever it is. Um, and um, So it's a pain in the butt. So that's why you use a proxy with like the LLM. And then the second piece is what that lets us do is basically establish reputation. It's still hard for them to game. They could say, I'm the super best forecaster in the world, whatever, whatever. I know the best thing about machine learning. That still doesn't actually get you info gain with respect to progress on a benchmark reliably. And so basically, if you backprop from this thing that's doing all of these forecasts, it'll tell you what they're actually good at, what their information is actually useful for.
So the benchmark in your sort of use is as a source of predictor of people of predictors, like people predictors, like
Like,
people
why
that
am I
are
using
predictors.
the forecast bench?
Yeah. Like
Yeah,
what?
yeah, yeah. It's because in order to make this work, like, you first off need to have calibrated predictions to some degree. Like, you need a system which can take a bunch of qualitative data and then turn it into a, like, use that to elicit a persona that will make forecasts like that person would have made. So it
Mhm.
is strong in areas that they would have made a strong forecast.
And like, what's the sort of like the vision would be that you would have a model that could take information about a person and then uh like somehow like run inferential questions to determine if they're this kind of sort of non-consensus
Exactly.
reliable. Okay.
Exactly. And the purpose of this is to basically figure out who is actually strong at what,
Hmm.
you know, in
Hmm.
a way that you can't game and that doesn't take a lot of time and energy for that person. Because one
Yeah.
basically the crisis that we have right now is like there's so much crap on the internet. How do you know what's true? How do you know who's right? And if you look at an institution gives you a credential, or if you look at like peer review, like all of these systems are being broken. Like you need something which is like a thing that is impossible to game. Like basically in this case that it becomes or extremely difficult to game, which is that over time we get more information about things in the world, right? And if that is true, like then it becomes easier for many people to agree about some like whether or not some event was true, like evaluate it to true. And you can also, as an aside, like make these criteria. So like resolution criteria is like a whole area of this. Like how do you decide who says that something resolved to true or not? Um, but even so, you can say like we both agree that we'll abide by whether or not NOAA says something is true with 25 hurricanes. And then you could say, well, the Trump administration might say that, put the finger on the lever because they don't want, NOAA to say this versus that. And like that all needs to go into your world model, right? Of whether or not this thing will resolve to true.
Right. And like is the idea that the source of these people's preferences will or like predictions will have to be out there somewhere, or you would elicit them when they like enroll in the system, or like
No, the goal is to be able to do this based on conversations with them, based on conversations and information. So like your scholarly works,
yeah,
like your like interactions that you've had, like this sort of information, like projects that you're working on. This actually has information that you can
yeah,
use to make forecasts about things. So I'll give like an easy example. It'd be like let's say that I just ran an experiment that like beat super forecasters, okay, on
hmm,
some benchmark, right? Um, you might ask a bunch of other people who didn't just do that, like, what is the likelihood that someone's going to beat super forecasters on super forecaster bench, right? Um, by like the end of May, right? And then they might say like, oh, it's like 50%, 80%. I'd be like, I'm going like 99% here because I'm looking at like the results and I'm like, I think I got this, right? And so I have asymmetric information about this topic, right? And what that would tell you is that if that person is then trying to like who
right,
would be able to help tell you about who should you believe when they say something about progress on forecasting using language
right,
models, then it's not just my peer says I'm this, it's like it is another mechanism by which you can
right. I guess
arrive
I
at
was just
this.
wondering about like the forums where people would be providing these sort of outlying predictions.
You don't the person there's no elicitation of human forecasts involved
Right,
in what I'm proposing.
right.
Yeah.
So
No.
you would
I'm just
just,
using the super forecast bench to kind of like build the system.
but the
Um,
example of the experiment is visible within the system because it was done by an LLM of a user that has registered
yes,
in the system, and the LLM
yes,
is sharing that
yes.
information.
We're under the hood. Under the hood,
Yeah,
we can
right.
register a bunch of forecasts, and we
Yeah.
can look at these registered forecasts in 6 months and see which of them were non-consensus and right.
Mhm.
And that's going to tell us about the reputation of that person.
Okay.